Hello everyone, welcome to our meetup, Open Data Science Paris online meetup. And today we have a great speaker. So I would like first to tell you a little bit more about ODS community. So to start, it's a Slack community with around 45,000 members, 6 million messages, and also there are so many activities made by this community. For example, a Telegram channel for data science news in English, or also you can see that there are people who are doing great work and great tools like DVC, open source version control system, Catalyst, it's a PyTorch framework for deep learning, and also image augmentation library, Albumentation. It was made by ODS members and Kagglers. I would not say that it's an ODS product, but you can definitely find channels at Slack community and ask directly people who created all those stuff, and I find it really cool. And also you can find really nice pictures in documentation for albumentation, like a very cute fox, like you see now. So yes, and if you would like to join, it's possible to fill out the form, but it could take for around 2 weeks or 3 weeks for approval. Yes, and so today I would like to tell you a little bit more what to expect today. So Artyom Palvelev, he's Kaggle master. He's working now in Manchester. So he will present his recent experience in Kaggle competitions, recent 2 competitions. Then we will have some time to ask him questions, and you can ask directly in the chat. So other organizers, Anton and Evgeny, they will read, and then we can just really ask most interesting questions our speaker. And then I will tell you some about some new Kaggle challenges, and after that we will do a video networking via Icebreaker, so stay with us. And now it's time for a presentation, and I'm giving control to Artyom.
Okay. Hi guys. I hope you can hear me and everything's cool. Tell me if it's not. Okay, so I wanted to share a bit of my experience with Kaggle and Kaggle competitions and and maybe my story how I got into data science. So about my background, I spent many years in game development, made a few games, and then I decided to switch to machine learning and took some Coursera courses, and I decided to try myself in Kaggle. And yeah, I'm working and changed my career path a little bit. So I'm working as a machine learning engineer in ARM since February. So, and I wanted to share with you, yeah, my Kaggle experience and what good and not so good things there are about Kaggle, maybe. And so, yeah, I wanted to share with you that well, if you ever seen Kaggle, then sometimes it's difficult. Like if you see a leaderboard which is full, like which has like maybe 5,000 competitors or like 10,000, it's really hard to get into top 10. So like my personal trick is to just pick hardest competitions, which everyone is afraid of, so that there's not so many competitors and it's just easier to do something. And for example, last summer I participated in YouTube competition, which had like It was classification task from YouTube, and there was most people were afraid of participating because it featured like terabyte of data. But actually, I made a very simple network, which was like 2-layer perceptron, 2 layers, and this was enough to get a silver medal, get a place in top 30. And this was quite easy. And another interesting experience was that when, again, last summer and in September, I participated in object detection challenge by Google, hosted on Kaggle, and the only chance, and I realized it just challenge is just too difficult because just training a single model takes like 2 weeks. And even though I had 4 GPUs, this happens on 4 GPUs, like about half of a month. So, and it was just a bit late to participate. So I decided that the only chance would be to try TPU models. And I got some TPU quote, so I could use TPUs for free for some time, and actually that worked. And yeah, I got hands on very new hardware, and it was interesting and hopefully useful. Well, definitely a very useful experience. So, but on Kaggle, either you get medals or you get experience. Experience is what we get instead of what we want. So I'll tell you about 2 competitions, and once I got medals and another experience only, essentially. And yeah, but yeah, I just wanted to quote like the current top 1 Kagler who says like if you're racing for the medals, then you can lose, but if you after an experience and knowledge, then you can never lose. Okay, then I wanted to tell you a little about this competition, abstraction and reasoning challenge, which was maybe the most difficult competition on Kaggle and most unusual. Let me show you. So it has like, we have to write a program which will be able to solve tasks like this. It has pairs of images like input and output. So we have to understand what's the dependency between inputs and outputs and make a prediction on a test image. Like for example, if you look at the right image, obviously it sorts. It asks a program to find the tallest bar and the smallest bar and paint them in different colors. So it always gets an image on input, like between 2 by 2 and 30 by 30 pixels, and it has to do some tasks. Like if you look to the left, this means I guess the program is supposed to crop images around, crop the background around some non-trivial image, and that's it. A couple more examples. Yeah, if you look at the right, this is like a Tetris task, right? And yeah, it's about moving pieces. And if you look to the left, then this uses like something like mirror reflection, and yeah, reflect, swap. It's like flip left to right, flip up to bottom, and multiply and increase image. So note that input image shape and output shape are not the same. They might differ. So the program must predict the shape as well. And all pixels of image must match the real output. Then this task is solved. Otherwise, task is not solved. This is the metric. So it's accuracy, like either it's solved or not. And so the challenge, we had a training set which had 400 tasks like this, and we had evaluation set which had 400 tasks which were significantly harder. And every task is like 2, 3, or 4 samples like above, and then it has to make a prediction on one more test sample. And it was evaluated on a test set which had like 100 hidden tasks which we can't really see. So yeah, actually, before going forward, I would encourage you to think like what can you make any machine learning model which would solve tasks like this, like moving pieces or doing something with mirroring and reflection, or like drawing lines or something? Yeah, it's supposed to be a non-trivial machine learning task, but I don't think it's really connected to something like artificial intelligence. Okay, let's go. So some possible ideas like cellular automata. If you ever seen Conway's Game of Life, it's a simple game, simple game which has a few simple rules. It has field of like pixel grid and some rules regarding to neighbors, and like if there are like 3 neighbors, then maybe paint something, and if there are less than 2 neighbors, then paint black or something. Okay, another idea was genetic algorithms. It sounds cool, but actually they're very sensitive to metric choice. It's difficult to find a proper metric. And it was all about searching for the right DSL, a domain-specific language. For example, we might come up with DSL, which would be like, let's imagine all possible programs which paint lines or move something or flip something. And yeah, so essentially we have to write we have to make a model which would write a program or something like this. Yeah, okay, hard-coded. Okay, obviously it's possible to hard-code every particular algorithm, but the problem is that the model is supposed to work well on the new unseen samples. This was the whole idea of this challenge. Okay, gradient boosting. There was a notebook which demonstrated that gradient boosting actually works, and it's possible to. Well, the problem is that we have only like 2 or 3 samples per image per task. Sorry, 2 or 3 samples per task. So most of traditional machine learning or data science approach do not work in this case. But if I imagine the task that like a per pixel task, then it actually works. And it turns out that traditional data science just works. And regarding BERT, that was an exotic idea, but I don't think it really works. It probably just overfits. Okay, so what we made? Yeah, so we came up. Well, I was solving this in a team of 4 people with like 3 different solutions. So I, with my teammate, we were working on a genetic algorithm on top of a DSL, which was quite powerful DSL, a domain-specific language, which was using cellular automaton, and also it could draw lines, move things, make calls, and so on. And we optimized this. First, we made a program in Python, and then we optimized it. Then C++, which accelerated it like by 2 orders of magnitude, maybe 100 times. And our teammates made 2 more DSLs, which works for some particular cases. For example, we noticed that sometimes output is just a cropped version of an input, so that we just made an algorithm to search for this, and so it worked. But one unpleasant thing about Kaggle, and one loophole maybe, was that, as I mentioned, the test set was hidden, but it was not completely hidden, because you could get access to it. And so we make a submission. Every time we make a submission, it's executed on a private test set, which we can't see, and then it might fail or succeed. So by failing the submission, we can actually get like 1 bit of data from the test set, which is maybe not so cool, but we can actually get more information by using timing. For example, yeah, okay, but long story short, we can get some information. So we can actually discover if there is a small, like 3 by 3 image in the test set, then it's just possible to get it completely, get all pixels, which is, yeah, so this is called LB program basically, and you can see the signs of LB program, that some people do like about 20 submissions, and other people do like about 200. So it's noticeable. 200, like between 100 and 200. Yeah, and problem is it was not clear if it's really legal or not. And so we decided not to do this. And eventually we ended up on in the gold area on 10th place, but we could do this as well. And this would raise our score, but I think it's not really honest or interesting. So we didn't do this, but yeah, but it turns out they didn't. Kaggle decided to keep all LB probers, so nobody was removed. Okay, that's their decision. I don't know. Okay, conclusions about this particular part. Well, it was interesting. It was interesting, but to be honest, I spent 3 months on that, and I created like 5 different GitHub repos and spent a lot of time. And one weird thing about Kaggle that, you sort of working for free if you're not getting prize money, which is very rare. Yeah, and this LB problem situation, I hope it will be fixed someday, maybe, but it has been reported like last summer, and it's still not fixed, which is a little upsetting. Okay, let's move forward. I wanted to tell you about another interesting competition, a 3D object detection competition, where we mostly got experience, not medals. But it was interesting. It's used for, 3D object detection obviously is required for autonomous vehicles. This is how data looks. So they have a car with 7 cameras and a LiDAR. LiDAR scans in all directions and returns the distance to the nearest object. So it returns a point cloud in 3 dimensions. And there are 7 cameras, 6 cameras like front, back, left, right, and front zoomed, and top, and something else. Okay, and we have a lot of data, like half of terabyte of data, I think. No, maybe 100 gigabyte of data, a lot of images, and a lot of point clouds. Yeah, so this is how it looks roughly. So it returns the distance to the nearest object. So you can spot the car in the middle because the LiDAR rotates around this car. The car itself is not visible, but you can see circles where the car is. And you have to guess like what's around the car. These are our labels. So it can only see car from some angle. So it can only see one corner of the car. And the metric is it's a standard metric for object detection. It's just intersection over union, basically, average for between all classes. Okay, I just want to share some basics in case you have never done 3D object, 3D point cloud tasks. So there is a PointNet. PointNet is a very basic classification model. It takes just point cloud and it performs a classification task, like if it's a macro table or something. And it uses convolution. It's a convolutional networks, and it uses, which is cool. So it can be run on GPU, and it uses pooling to guarantee order invariance, because obviously the result should not depend on the order of points. which you can provide in any order. So it's a convolution network, and it just works and it's cool. Another more complex model, one of the first 3D object detection models was made by Apple in 2017, and it splits point cloud into a voxel grid and to 3D grid, and then basically it runs a convolution model on top. Well, to be honest, the simplest approach, if you go back to a couple of slides, the simplest approach is to just project all this data into two-dimensional grid and run just some traditional two-dimensional model. Like the easiest way is to just just use a bird's eye view, just look from top and project everything on a two-dimensional plane and use something like faster RCNN or RetinaNet, or maybe a segmentation model like UNet to differ from non-cars and non-cars. But obviously more interesting, this was too easy, like using standard model was too easy. So we wanted to use some powerful models. So VoxelNet is the first, maybe simplest 3D detection model. And well, another idea is our point pillars. It's a new model from last year. It also uses convolutions. Well, all these models use convolutions. Another more powerful model was point RCNN, which is similar to faster RCNN if you know how two-dimensional object detection works. So, and interestingly, this model does not use RGB images at all. Oh yeah, by the way, well, like previous two models also do not use RGB information at all. They only analyze point cloud. So this point RCNN, it was quite powerful model because they concentrated on generating a small number of high-quality 3D proposals, which then they can refine. So it's a two-stage network. Here you can see that AVOD actually is a model which combines two things, combines information from RGB image and combines 3D point cloud. The Frustum point.net is the same. Well, it's not same, but similar. They combine two kinds of information, and point RCNN only uses point cloud. And it actually works better than the first two models, which is fascinating. And another model, but a newer version of Frustum model, it uses two sources of information. It uses RGB proposals. It just takes any existing model as a proposal generator, like faster RCNN or RetinaNet, and then it obviously can detect cars on photos, right? And then we can make a Frustum. So we just don't know the distance to the car, right? We can clarify the position of this Frustum, position the box of the car in this Frustum using point cloud information. So this is sort of a three-stage approach. It takes two-dimensional proposals, then it takes it integrates it with point cloud information, and then it runs one more step to refine predictions. So, and this actually works a little bit better. So we tried last two models. We tried Frustum ConfNet and we tried point RCNN, and we didn't really succeed. And to be honest, we ran out of time. We started very late and we couldn't finish the work properly. And yeah, our place could have been better. I just wanted to share some experience with you. So on the left, you can see our predictions. So we trained Cascade RCNN, a powerful model from detection framework. And at the right, you can see predictions made by a winner team, some proper predictions, and they were using PyTorch.second framework, which I'll tell you later about. So yeah, problem was there was problem with data format. So all models traditionally use Kitty dataset, and Lyft models were provided in new scenes dataset. So we tried to use a converter, and there were problems with this choice. And it turns out that all winners just use this native format new scenes, and there is a library called PyTorch.second on GitHub, which just was basically working out of the box, and it was just a lot easier to use it. So we just ran out of time. We tried to implement two state-of-the-art models and just ran out of time, and we made an ensemble with a simple 2D detector and frustum constnet, but it was not working great. Yeah, and there were some problems with data again because car is moving and RGB images did not precisely match point cloud information. That was another source of bugs as well. So I just wanted to maybe share with you some experience. So Kaggle is great if you want to try something new. Maybe if you want to try, if you never did NLP tasks and you want to try, then it's a cool idea to just try something on Kaggle and you will get into things. Or if you never tried any computer vision task, then you can just participate in any competition. You'll get a ready data set, a predefined metric, and baselines, and maybe some hints on forum. And it's sort of cool to learn something new. And you get these big data sets for free and even get some hardware. Yeah, and okay, maybe not so good things. And to be honest, the unofficial title of this presentation was something like the Kaggle, the good, the bad, and the ugly. So the bad is that you're essentially working for free when you're doing Kaggle because usually you don't get prizes. Yeah, as I'm saying, I was solving this for 3 months. I was solving abstract reasoning challenge, and to be honest, I would better spend this time doing like maybe my pet project. So if you already have enough of experience, then maybe do your own projects, maybe get a life. I don't know. Spending all your evenings on this might be not the best idea, but if you want to learn something new, then it's definitely a good idea. Okay, I can see a question. How many hours of training did you spend doing Lyft competition? I don't know. In terms of hours, spent about a month. So, but to be honest, it's not like the problem is that we don't have a perfect code so that you can just train a model. You always have to do bug fixes. So essentially, we only trained proper models in the last 5 days. But basically, we were working for like about 1 month. Okay, and I think that's it. Do we have any more questions?
Thank you very much, Artyom, for your presentation. It was awesome. Yes, we have one more question from...
Question about image registration. I don't understand what is image registration. Can you explain? Oh yeah, by the way, another idea was to use tracking because yeah, there's a task called object tracking because sometimes when you're tracking cars, for example, tracking moving cars, a car sometimes can get behind an obstacle, like behind the bars, but you still have to predict where it is.
There is a question from Tatiana Shpakova. Did you try other competitions and platforms?
I never tried any other platforms, I think. To be honest, Kaggle is the most popular platform and the most crowded one. So I guess it's the most difficult to win on Kaggle. And I don't know, it's not. I think it's a good idea. It's easier to it's definitely easier to get prize money somewhere else, but I don't know. I didn't try yet.
And another question from Alexander Boyko. Have you considered image registration between
Yeah,
RGB and point cloud?
I think I tried to answer it, but I don't understand what image registration means. If you can explain. Okay, person transforming different sets of data. Well, okay. Well, obviously all data is supposed to be in one coordinate system, right? But well, problem is that well, it was just a software bug in the converter which we didn't know about, and so we expected them to be in the same coordinate system, but due to just a bug, it was not precisely true, and this just spoiled object detection accuracy. Well, actually, all I was trying to say that when we using two sources of information, it makes it more difficult. We they must be precisely tied to each other. If there is a discrepancy, then you'll have problems. And if you make a simple baseline, then uh, maybe it's easier to make a baseline on just one source of information first. Uh,
Yeah, Alexander
no,
wrote.
actually, I'm not saying point clouds were not precise enough. Actually, because Wiener's models only used point cloud based models. Yeah, so Wiener's actually used voxelnet and point pillars mostly. And it's weird that the oldest model, voxelnet, was actually prize winning. And I guess it's just because we had not enough time just to polish better models.
Thank you very much. I don't think we have other questions. Thank you very much. And as I remember correctly, for the first competition, you shared your code, right? No, not really.
Yes,
Yes.
well, I try to always share my code, but yes, if you open this Kaggle forum, there will be linked our 10th place solution with code, and yeah, you can find our code.
And your team won a gold medal on this solution, on this competition. Have other teams also shared their code? So it's quite common to share your work experience with others on Kaggle.
Yeah, but usually people who did LB probing didn't share their code for obvious reasons.
All right. I don't think we have other questions for now. Thank you very much, Artyom, for your
Okay, cheers,
presentation.
guys. Hope that was interesting or at least funny. Cheers.
And it's not over yet because I will tell you about more upcoming challenges, and also we have a networking part. You can find join link in the chat, so we will have some video chat between us, and also Evgeny will tell you some latest news in machine learning and data science, so don't miss it. And more challenges now. I think 1 week ago Kaggle published new challenges. First is Cornell bird call identification. It's the task is to classify bird songs, and dataset is awesome. There are 23 gigabytes of bird songs, and you can just listen your data and relax. You have 3 months to go for this competition. And another one is a Halitea by 2 Sigma. It's a reinforcement learning competition, and for both of them you have 3 months to go, so a lot of time. But don't miss, in 1 week we will have another presentation about machine learning in production, and Maggie Mhana from Renault Digital. She will talk about how to push TensorFlow models into production. She has great experience at Renault Digital, and she will share her real work experience. So I would like to thank Anton Doroshko, Evgeny Bazarov, their organizers also of this meetup, our speaker. Thank you very much for your presentation, and Karina. Sorry. And Karina, who inspired us to go with this meetup online. She made an awesome meetup, London PyTorch meetup in London, online during those virus days, and we found a great inspiration in this meetup, in our workflow, and thank you very much, Karina, for this. So that's it. See you soon in an icebreaker, and take care of you. Bye.